Good morning to all. In this session, we are going to study about maximum mode system with its timing diagram. In the previous session, we have discussed about minimum mode system. So as you all know that how this microprocessor will be operated in minimum as well as maximum mode system. That depends on one pin which is Mn by Mx bar, minimum or Mx bar. So if Mn by Mx bar is equal to 1, then it will be operated in minimum mode. And if Mn by Mx bar is equal to 0, then it is operated in maximum mode system. So in the previous session, we have studied about minimum mode system. So what is minimum mode system? Nothing but if the 8086 processor is itself a controller or master or give the commands to the peripherals whatever is present in our system in order to operate accordingly. Nothing but 8086 is its master. So here all the operations will be performed by the ALU present in your 8086. Whereas coming to the maximum mode system, maximum mode nothing but its control will be shared with other functional unit, or nothing but its operations, its functions will be done by the other functional block. Like for example, adder, subtractor. Okay, so here ALU is present in our 8086. So in minimum mode, it is the only functional unit which will do its operations. But in maximum mode, they will be having some other functional unit which will be doing its operations accordingly. So where we are using this maximum mode 8086 system is when the processor requires the help from the other functional units to do its functionality. So if we are going for a complex system design, in such case 8086 alone cannot be able to do its operations, do all the operations. So it will share the information with the corresponding other functional block in order to process the data. So this is where we'll be using our maximum mode system. So similar to your minimum mode 8086 system, we have clock generator which will be able to generate a clock which will be synchronizing with our 8086 inbuilt clock with the help of a crystal oscillator of some 5 megahertz of frequency. Clear? Next, it will be having a latches, it will be having a data buffer, or I can call as transceivers, which will be acting as separators between address and data lines. So this they will do with the help of data enable and data transmit or receive bar, whereas the address can be able to demultiplex with the help of ALE, as we all know, right? So as 8086 processor has 20-bit address bus, so when ALE is enabled, it will enable the latch to store address bus. So this latch, we have a 8-bit latch. So in order to store a 20-bit address, we will be requiring 2 or 3, maximum 3 latches. To see here what is the difference is in minimum mode and maximum mode. So depending upon the selection lines S0, S1, S2 are being given to the controller, which is 8288. So now this is the additional processor which is being used, and this is controlling all the process which 8086 need to do. Getting a point? So see here, ALE is present here, which is being enabling the address latch in order to separate the AD02, AD16, AD15 address and data buses, where these latches will separate only address bus, which is A0 to A19, which is 20-bit address bus. Similarly, data enable and data transmitter or receiver bar, these two are the control signals for the data buffer in order to separate from AD0 to AD15 as D0 to D15. 16-bit data bus, as we all know. In 8086 processor, we have 16-bit data bus and we have 20-bit address bus. Then, now, so we have some control signals. Depending upon these control signals, the controller will be doing the operation. Okay, which is IO read, IO write, memory write, memory read control. So depending upon these three signals, which are S0, S1, S0, S2, S1, S0 bar, depending upon these three, this IO operations or memory operations will be done. Memory read or memory write, IO read or IO write. Okay. So what is the difference now here? All the things are happening according to the 8086 processor only. But the thing is, the 8086 processor has given the control to the 8288 in order to do its task. This is the only difference between your minimum mode and maximum mode 8086 system. So it will do all the operations taking the data from the memory with the help of a BHE bar and A0. So it will select a odd bank or even bank, and depending upon that one, take the address and take the data depending upon what address is being latched, and take the data and store into the data buffer, and depending upon peripherals you can go for write or read operation from the memory and the IO. This is how your maximum mode 8086 system works. This is the simple diagram which we can understand by its operation. So as we have seen that 8086 is operated by making this Mn by Mx bar as, we need to make as 0, right? So 0 means what? 0 means what? Ground. Ground. So in this mode, the processor derives the status signals S2, S1, S0 to the other chip which is acting as your controller. Which derives the control signal using the status information what processor requires. In the minimum mode, directly the processor will be giving the control signals. Getting a point? Whereas in maximum mode, the another chip called bus controller will be giving the control signals depending upon its status information. In the maximum mode, there may be more than one microprocessor in the system configuration. So there can be more than one microprocessor in the system configuration. The components in the system are same as your minimum mode system. The basic function of the controller is what is? It is nothing but to give the control signals like read or write from memory and IO device, and data enable, data transmitter or receiver, ALE, etc., etc. Using this information by the processor on the status lines. So they have the input lines as S2, S1, S0 and clock. These inputs are given by the CPU. So AE and address enable and IOB input output are generally grounded. CN pin is given to your 5 volts. So all the functions will be depending upon this table, which is status code S2, S1, S0. The same operations what minimum mode have done. Only thing is here the bus controller will be controlling this all the signals. Now coming to the right, memory read timing diagram, how it will read the cycle. So suppose we have given a clock pulse in this fashion where T1, T2, T3, T4, then again so on, T1, so one bus cycle. So ALE address slash enable, during this your address will be on A16 to A19, then S2 to S0. So depending upon your LE, if it is active, when it is active, your data will be A15 to A0 and memory read will do, because we are going for read. So whereas S2 to S0 are active, memory read operation does. When it is inactive, it comes to your high state, nothing but it is as it is bar, so it will be active low signal. So when it is inactive, it becomes as inactive. Data transmit or receive bar also acting as your memory read, and data enable will be low because we are not going for, we are going for read operation. So den bar should be low when it is active. When it is inactive, it should be high, as it is bar. Be clear with this bar. Bar means it is a active low signal. So it will be active when it is 0. When it is high, it is inactive. So this should be inactive. This should be active during active cases, and for inactive, it should be inactive. Data transmit or receive, as we are going for reading, nothing but receiving the data and read it. We are not writing anything. So at this active part, it should be at low because receive bar. Clear? This data A0 to A15, when it is active, D0 to D15. This is just an address from address 16 bits and data 16 bits. Then from where I need to, if I want to read, it should be low. Then I can able to read the data. Whatever the data has been received will be read, as well as if the data enable is 0, then only you can able to read the data. This is the read cycle for maximum mode. The last, memory write timing. Now here write nothing but we need to write the data. The same as your whatever the thing we have seen here. Until now, this is the read will be low when it is active. It will be high when it is active. It will be low when it is inactive, because we are not going for read. Now it is write. Write will be high and low for inactive. Here the write operation, this both should be high, this both should be enabled in order to write your data from into the memory. So this is the timing diagram of maximum mode 8086 system. Thank you.